Okay, so I want to show you some more calculations dealing with this grand topic, stoichiometry. I'm going to use the reaction we did in lab, where we took sodium carbonate, reacted it with 2 hydrochloric acids. It produced carbon dioxide, which you saw bubbling up. Also produced water, which was a little harder to figure out because these were aqueous to begin with, and 2 sodium chlorides. Now that's a balanced equation. Hopefully you kind of have draw a mental picture of what happened during that process. And now what I want to show you is the way you use this balanced equation to figure out the amounts of the materials that you need or are going to produce. Now the key to it is realizing this ratio of moles that comes about because you have balanced the equation. So I have a 1 mole to 2 mole ratio in the reactants. That is going to give 1 mole of CO2 plus a mole of H2O plus 2 moles of the sodium chloride. And what that was the coefficients that came about once I balanced the equation. Okay? And this is the key to pulling the whole thing together. So let's go back to the lab. So what we did in the lab is I gave you guys, or said to start with 2 grams of sodium carbonate, and I wanted you to figure out how much sodium chloride in grams you were going to produce. So this is part of the process. Now, when you have a balanced equation, all you need to know is the amount of one of the substances, and you can figure out everything else, and I'll show you how that works. But first, I want to solve this problem. The way I'm going to solve it is through dimensional analysis, which is the classic way that a chemist would solve this problem. I want you to try to do it this way too. Along the road, you're going to find other ways you can solve these, which is fine, but initially try it this way. What I want to do is I want to turn this 2 grams right here into moles, because once I have an amount defined by the number of moles, I can take advantage of the ratio of moles that has been defined in the balanced equation to figure out whatever I'm looking for. So here's how it's going to work. I'm going to start off in this space right here, putting down 2 grams of the given amount. Now I want to convert that to moles. The way I do that is I say, all right, for every 1 mole, there's going to be some mass. Well, the mass comes from the GFM of sodium carbonate. Sodium carbonate happens to have a mass of 106 grams per mole when I add it up. It comes from 2 sodiums at 23 apiece, a carbon, which is 12, and 3 oxygens at 48. All added up comes to 106 grams. We've done this. This little piece right here is nothing more than a mole conversion. Now, what I want to do is I'm taking advantage of this mole ratio deal, where 1 mole of sodium carbonate begets 2 moles of sodium chloride. Well, the 2 moles of sodium chloride goes right there, because that is what I am looking for in ACl. 1 mole is what I was given. So this is the 1 mole of sodium carbonate, Na2CO3. And the reason why I'm doing this is mathematically I'm just sitting there saying, okay, however many moles of sodium carbonate I have, I'm going to ultimately end up multiplying that by 2 to get the moles of sodium chloride. And I'm taking advantage of that 2 right there. Now what I want to do, since I'm looking for my answer in grams, is convert this amount into grams. The way I'm going to do that is the fact that sodium chloride has a mass of 58 58.5 grams for every 1 mole. And now realize that this is the sodium chloride that I'm talking about. The moles over here were the sodium carbonate. And when I look at the units of this problem, okay, I have grams here, grams there. Those will cancel. Grams and grams are gone. I have moles of sodium carbonate with moles of sodium carbonate. So those units are going to cancel. I have moles of sodium chloride. They're going to cancel with moles of sodium chloride. My answer will be in grams right here, which is what I'm looking for. I'm now going to just take my calculator and do the math. So it's going to work like this. 2 divided by 106 times 2 times 58.5. And my calculator is set up to just do this. That 106 times 2 times 58.5. So that means I should have gotten 2.2 grams of NaCl produced. Now that's going to be the theoretical yield that comes out of this. All right? Okay, let me solve for another one of the products. Going back to what's given, okay, and I want to write this out again so you have it in front of you. I have sodium carbonate, 2 hydrochloric acids, HCl, producing a CO2 plus H2O plus 2 sodium chlorides. Now this time, let's say I again start with 2 grams of the sodium carbonate, but I want to figure out how many liters of CO2 I'm going to produce, and just to be technical and correct on the whole thing, at standard temperature and pressure. For right now, just ignore what I just did. Later we'll change it, but it does make a difference. Alright, so this time I'm looking for the amount of CO2 that bubbled up. How much did you see coming out of that evaporating dish when you did it? Well, I'm going to go back to this 1 line, 3 lines coming down. I'm going to start off with the 2 grams, which is given. I am now going to change that amount into moles, realizing that a mole of sodium carbonate has a molar mass of 106 grams. Okay, I'm looking at the mole ratio from the balanced equation that says there's going to be 1 mole of sodium carbonate for every 1 mole of CO2. It's 1 to 1, right? So there will be 1 mole of CO2 for every 1 mole of sodium carbonate, Na2CO3. Having a hard time writing it all in there. All right, and then the final step is I want to convert the number of moles of CO2, because that's what I'm in right now, into liters. Well, there happen to be 22.4 liters for every 1 mole. It doesn't matter what gas it is, but this particular gas is CO2. Look at the units. Check myself. Did I do okay? Grams over grams, that's good. Moles of Na2CO3, that cancels. Moles of CO2, that cancels. I'm taking my calculator now and I'm going 2 times 22.4 divided by 106. And your calculator can handle that as long as you just input it. It's, commutative, whatever. Doesn't matter which order you do it. 22.4 times 106. So, yeah, I better be sure to divide it. 106. I ended up with 0.42 liters